Dear students, welcome to a brief video in which I demonstrate how we can use simple equipment and combine it with basic principles of gravity so that we can determine the mass of the Earth with our own gravimeter. This formula up here has been derived in the previous slides, and it tells us we can determine the mass m of the Earth by measuring the travel time of a freely falling test mass that is subject to the Earth's gravitational field and travels over a certain distance x. This approach assumes that we know the gravitational constant g and the radius of the Earth r. Well, it seems easy enough to do that. All we need to have is a test mass, the mass of which doesn't really matter. We need to determine a distance x along which this test mass should travel, and then we need to measure the travel time that it takes to do so. Okay, let's start with the easier part, that is to determine the travel distance for this nut, okay? And in my example, it's 77 centimeters from the top of this ledge to the top of the table. The more intricate part is how to measure the travel time, okay? And I tell you how not to measure the travel time. You don't measure it with two hands, one hand that initiates the fall and the other one that presses start on a stopwatch and then presses stop when you think that the nut has hit the table, okay? I tried it, data are all over the place, and the reason is our brains are not very good at synchronizing different events with the required precision, or at least my brain isn't. So we need something smarter, and that smarter thing is a smartphone, okay? So in the following, I will demonstrate the principle of a trigger, and I do that with a hammer, and this hammer I will use to initiate the fall by hammering against the metal ledge, okay? However, this hammer blow will also do a second thing, and that is the initiation of a sound wave. That sound wave will travel to my smartphone. That smartphone records this sound wave and uses that information to start the travel time measurement, okay? Then the nut is falling, and once it hits the table, a secondary sound wave is emitted, and that is used to stop the travel time measurement, okay? This concept is called a trigger, and you will see this kind of system also in, for example, seismic surveys. But for now, let's see how this will play out for us. So I will now initiate the trigger. Then we need to be quiet, because otherwise the trigger will be falsely triggered. Okay, well, this was our first experiment. Okay, the time that our mobile phone here has measured is 0.395 seconds. So I will write this down, 0.395 seconds. And what remains to be done is that we repeat this experiment multiple times so that we can constrain uncertainties, and then we can also change some parameters, for example, the height of the fall. So I will do this for you, and I will see you in a second or so.